Kelsey, I saw that you responded to Fred's comment explaining like how you could advance the machine learning training. Could you also speak to extracting exposed bedrock as opposed to sedimentary cover?
If you so if you knew what what a boulder looked like in or a bouldered area looked like in radar, which I think Caleb Bassett had talked about earlier today. But if you could if you knew what the pixel color looked like for that um, however you chose to display it in that raster data or however you coded that pixel, then you could incorporate that as a layer in your multidimensional raster data set, and then you would just train that schema or create an extra feature within your schema that says this is what a boulder looks like or this is what an outcrop looks like, and then it would use that as part of its search criteria. So that boulder would have maybe a rougher surfaced area, a different thermal inertia than the surrounding terrain. You could use that, and then uh, those kind of stacked layers together, those layers of evidence, is what would classify that as a bouldered region instead of the just regolith cover. So it's just how much you want to do supervised learning or how much you want to train the machine learning algorithm.
Okay,
This was just a test to see if we could do it.
seems very encouraging.
Yeah.
Thank you. Carolyn, I want to jump over to you. Brad asked about when or where the final repository for the map that Lucas made will be. And you mentioned the Europlanet GMAP project. I was wondering if you could speak a little bit more on that project and maybe its affiliation with the plan map, which you also linked in the chat.
Yeah, sure. So here on the other side of the pond from you guys, we've had funding from the EU over now, it must be like 8 years for supporting, planetary mapping in different ways, defining standards for non-standard kinds of maps, and kind of taking the USGS standards and then building on them for normal kinds of maps that come into publications that aren't necessarily going to be published as an official map plate. So the plan map project ended, but the website is still live. I linked to that, and there are a number of maps that we made that are present there that you can get a map plate to print out as an A0 poster size. But then there are also shape files and also the even off et al. 2018 Apollo Basin region map of the SPA. All the supplemental data are available there as well. And then the follow-on project is GMAP, which is part of a Europlanet sort of research infrastructure. And that we're basically doing more of supporting community geologic mapping. And so there's a regular winter school that everybody can join remotely. I'll put the link for the next one. The next one is going to be in the January, end of January, beginning of February of next year. So I would encourage anybody to take part. A lot of the presentations and materials are also just available online, so you can do it asynchronously if you'd like to. We've moved away then from actually putting the map layer packages and things on the GMAP website and just link to them in Zenodo, because that's kind of, you get a DOI for it, and it's just a better way to memorialize all of the work that's been done.
Right. Yes. Okay, thanks for that summary.
Yep.
We have a question in the chat from Laz to any of the speakers. Can someone describe what is expected to be different for areas with different regolith texture? Is it something astronauts are likely to be able to observe?
I guess I can take that. Most likely, yes, because based on the reports from Apollo, I remember both Dave Scott as well as Jack Schmidt related that they were noticing more ropey textures on steeper slopes and so forth. So that's definitely one reason why we should be interested in regolith texture. Also, soil stability for traverse and also engineering applications later on, but first and foremost for traverse. Yeah, there are areas where the rover might already slip on only 8 degrees, and others where it might stay more stable on 12 degrees, depending on the rheologic properties of the regolith there. And mapping out the textures can give us at least a hint how much the regolith is responding to the slope in a certain area. But yeah, the astronauts did notice in Apollo.
I
Yeah.
also could add, I feel like it would be something that they would be able to feel too. If
Definitely.
illumination is really like if everything around you is really bright, you're still going to be able to feel the difference. And like Hannah said, the textures are really closely related to slope. Maybe because if it's really highly illuminated, you're going to lose volatile support in like your interpore spaces, and so you end up with a little bit more compaction. And I feel like you would definitely be able to feel the difference when you're walking on it or driving on it.
I'd like to add to that if you don't mind.
Yeah.
Okay, so yeah, those two previous comments of you all are really relevant. A critical item here is that we simply do not understand downslope movement on the moon. Okay, so Hannes described the elephant tide terrain, and we don't know how that forms. Okay, there's a bunch of different theories, et cetera, and all of this is related to fundamental questions about lateral diffusion in the regolith, models of impact and placement and downslope movement of materials. And we don't know a lot. So this is something we really need to put in. I think if you can determine these different textures, it's really important to do that because it's not so much actually trafficability, which is critical, but it's also like, oh, wow, okay, so let's see what the structure is as a function of slope and different textures on the surface. That would be incredibly important. Thanks.
Thanks for adding on to that.
If we've gotten down to Jim Skinner's kind of discussion point, I'd like to jump in on
Please go ahead.
that, if that's okay. Yeah, so I mean, Jim was just writing in the chat that you know, how well do we understand the difference between the geomorphology and the geology that we're trying to map, right? And so the uniqueness of the different units. This is something that we've given a lot of thought to in terms of also just what do you call the map? You know, a geomorphologic map is not necessarily a geology map, right? So what we like to try to do with our maps is to layer additional information in there. So start with the geomorphology because you can see that there are different units that have radically different geomorphologies, but then add things like absolute model ages that give you some age information to help differentiate things. Add some you know, Clementine data or some other compositional data to give you a bit of a idea of mineralogy or rock types, and then we're moving towards a geologic map. But I think you're right. It's really important to understand the limitations of what we are representing, and what this may mean for, you know, mission planning using these maps.
Thank you for that input. And for underlining the need just for clarification of what we're actually presenting in all of these map products that we're making. I am going to end it there.